All right, so let's keep talking about this. So, as we were saying, in the blue line here, x is 4 and 4 only. X cannot be anything but 4, but y can be anything in the world, and that means y can be any number from negative infinity to infinity. Okay. Um, and another word about this is, um, you know, rate of change is undefined. Another way of saying that is the slope is infinite. Slope is infinite. Um, and slope is just steepness. Slope is just steepness, and so a very easy way that we can understand this is, you cannot walk up a vertical wall, right? Um, that vertical wall is infinitely steep. It's just straight up and down. Gravity is working completely against you. Um, so, you know, that's sort of the way that I think about vertical lines is they're infinitely steep in this way. You can't walk up them. Okay. Um, so good. So these are sort of the situations that can occur. Um, so what is next? What's next? Yeah. Okay. Sorry for the delay there. Um, Almost finished with this little section. Um, so as x increases, y increases. So what we can do is we can get a little more mathematical. We can say as x increases, what that means is this: is that delta x, which is x2 minus x1, is positive. Okay, and what that means is this: is that if you have 2 points that are pretty close together like this, um, that x2 is to the right of x1. So in other words, this is the x2 and this is the x1. Okay, so um, that's what we mean by delta x is positive. Same kind of thing over here. Delta x is positive, so that means that if we have 2 points, this is x1, this is x2. And once again, x2 is to the right of x1. Okay. And then y increases, right? So that means delta y is greater than 0 in this case. Now, for decreasing, I'm sorry about how jumbled this is getting. For decreasing, delta y is going to be less than 0, but delta x is still going to, oops, I wrote that backwards. Delta x is still going to be positive. Over here, no change in height. That means the change in y is going to be 0. I can't believe I'm writing those backwards. Delta x is still going to be positive over here. And over here, delta x, the change in x is exactly 0, because x can be 4 and 4 only, okay? And delta y can be absolutely anything. Okay, and let's just go ahead and just write an expression for slope, and we'll call it for this first video. So, slope from good old algebra is just y2 minus y1 over x2 minus x1, and we can abbreviate that as delta y over delta x. Okay? And in the case of an increasing function, the slope is going to be positive because both delta x and delta y are positive. We could have a decreasing function. For a decreasing function, the slope is going to be negative. And again, because delta x is positive, delta y is negative. we could have um, zero slope, or not increasing or decreasing. This means that we are at a max or a min, or otherwise we're just at a point where the slope is zero. Okay, so yeah, again, three possibilities there. You're either at a max, or you're at a min, or you're at some other location where the slope is zero. Okay, and so that's what that looks like. It's either here, or it's here. Okay, and then finally 4, um, the um, the slope could be plus or minus infinity. And this is where y2 minus y1 over x2 minus x1. This happens when the denominator becomes 0. Okay, so in other words, if x2 and x1 are the same, in other words down here, these 2 points here, this point and this point, the x values are the same. And so when I plug that into my slope, I get 0 in the bottom, and we know 0 in the bottom is undefined. Okay? And again, y2 minus y1 can be any number in the world. So we get some number over 0, and again, that's plus or minus infinity. And what does that look like? It looks like the little vertical blue line here. Okay? Yeah, so this is just sort of a summary of the first section about the different types of rates of change, and how we can think about change occurring at an instant.